Welcome to Sleepy Science Brain, and welcome to this journey through the landscape of dreams. For the next hour, let yourself settle in. There is nowhere else to be, nothing to solve or accomplish. Just a gentle exploration of that mysterious place the mind visits every night. You may drift in and out of awareness as these words continue. That is perfectly natural. Let the information wash over you like waves. Some of it will stay, some of it will fade, just like dreams themselves. Find a comfortable position. Let your breathing slow, and allow yourself to descend into this deep dive. There is a world that opens every night. A world that feels vast, urgent, and utterly real in the moment. And yet, by morning, it has almost entirely vanished. Most people dream not once, but 3 to 6 times every single night. These dreams arrive in waves, across different sleep cycles, each one a small theater of experience that plays out in the darkness. They are not rare visitors. They are constant companions. And yet, so few of them remain. Each dream unfolds over a span of 5 to 20 minutes. But time, in that space, does not behave as it does in waking life. A single dream might feel like hours. A conversation might stretch. A journey might compress. The clock of the dreaming mind follows its own rhythm, one that bends and distorts in ways that feel entirely natural until the moment of waking arrives. And then, almost as quickly as they came, the dreams begin to fade. Somewhere between 90 and 95% of all dreams are forgotten within minutes of opening one's eyes. The details slip away. The faces blur. The emotions linger for a moment longer, but even they dissolve like mist in sunlight. What remains is often just a fragment, a feeling, a single image, a sense that something important happened, though the specifics have already gone. This is the paradox of dreaming. It feels so vivid, so intense, so undeniably real while it is happening. And yet it vanishes almost completely, leaving only traces behind. The mind, it seems, is not designed to hold onto these nocturnal narratives. They are written in disappearing ink. But why? What is it about dreams that makes them so powerful in the moment and so elusive afterward? The answer lies not in mystery, but in biology. Dreams are most vivid during a particular phase of sleep known as REM, rapid eye movement sleep. During this time, the brain becomes remarkably active. Electrical patterns surge through the cortex, mimicking the kind of activity seen during waking thought. The eyes dart back and forth beneath closed lids, as though tracking movement in an invisible world. And in this state, the mind constructs its most elaborate, most emotionally charged, and most memorable dreams. But the body, during REM sleep, undergoes a strange transformation. Muscle tone drops away almost entirely. A temporary paralysis sets in, affecting nearly every voluntary muscle except those that control breathing and eye movement. This paralysis is not accidental. It is protective. Without it, the body would act out the movements of the dream, running, reaching, speaking aloud. The stillness of the body allows the mind to wander freely, without consequence. And when someone awakens directly from REM sleep, something remarkable happens. The recall rate for dreams jumps dramatically. Studies show that between 60 and 90% of awakenings from REM produce vivid dream recall. The dreamer can describe scenes, dialogue, emotions, and sequences with striking clarity. But awakenings from non-REM sleep, the deeper, quieter phases of rest, yield much lower recall. The dreams from those stages, if they exist at all, are harder to retrieve, more fragmented, less emotionally rich. This makes the experience of dreaming feel real and biological, not mystical. Dreams are not messages from another realm. They are the product of a brain in a particular state, weaving together thought, memory, sensation, and emotion into narratives that feel complete, even when they are not. But what exactly fills these narratives? What are dreams actually made of? Many dreams draw from what researchers call day residue, the thoughts, images, and experiences from recent waking life. A conversation from the afternoon might reappear in altered form. A face glimpsed on the street might become a central character. A worry left unresolved might manifest as a recurring theme. The dreaming mind reshapes these fragments, rearranging them into something new, something that no longer follows the logic of the day but carries its emotional weight. And yet, dreams are not simply visual experiences. It might seem that dreams are dominated by imagery, landscapes, faces, colors, movement. But research into dream content reveals something unexpected. Dreams are filled with thinking and speaking, internal dialogue, conversations between characters, narration. The dreamer often describes not just what they see, but what they think, what they understand, what they interpret. Dreams are as much cognitive as they are perceptual. They are stories the mind tells itself, using words as much as pictures. The characters in these stories are identifiable about 60% of the time. Sometimes they are people the dreamer knows well, family members, friends, colleagues. Other times, they are strangers, faces that seem familiar but cannot be placed. Occasionally, they are entirely invented, composite figures that the dreaming mind assembles from scattered memories. And yet, in the dream, these characters feel known. They have histories. They have intentions. The dreamer interacts with them as though they have always existed. And then there is the bizarreness. Not every dream is strange, but many contain elements that defy the rules of waking reality. A person might suddenly change into someone else. A room might open into a place that does not exist. Time might loop or skip. Gravity might fail. These impossible events occur most frequently during the middle of REM sleep, when the brain's activity is at its peak and its regulatory systems are most relaxed. In nearly half of all dreams, something bizarre occurs, something that would be startling or impossible in waking life, but in the dream, it is simply accepted. This is where the structure of dreams becomes clear. They are not random noise. They are not meaningless static. They are structured chaos, narratives built from the raw materials of memory, thought, and emotion, assembled according to rules that are different from those of waking life, but rules nonetheless. The dreaming mind is not irrational. It is operating under a different kind of logic, one that prioritizes emotional coherence over factual accuracy, symbolic resonance over literal truth. And so, each night, the mind enters this other space. It constructs worlds, populates them with characters, sets events into motion. It thinks, it speaks, it feels. It experiences time in its own way. And then, as morning approaches, it lets almost all of it go. What remains is just an echo, a faint impression, a sense that something vast occurred, even if the details have already slipped away into the quiet. The question eventually arrives. If dreams are so elaborate, so consistent, so deeply woven into the fabric of sleep, then why do they exist at all? What purpose could they serve? For much of history, this question was answered with symbolism, with prophecy, with hidden meanings waiting to be decoded. But the actual function of dreaming is both simpler and more profound than that. Dreams are not messages. They are processes. Dreaming supports learning. It strengthens the formation of long-term memory. During sleep, and particularly during the dreaming phases, the brain revisits information encountered during the day. It replays experiences, consolidates patterns, integrates new knowledge with old. Studies show that people who dream after learning a task perform better when tested later. The dreaming mind is not idle. It is sorting, organizing, deepening the traces left by waking experience. But dreams do more than help with facts and skills. REM dreaming, in particular, appears to play a crucial role in emotional regulation. The mind revisits emotionally charged experiences, but in a neurochemical environment that is different from waking life. Stress hormones are reduced. The brain can process fear, sadness, conflict, and desire without the full physiological arousal that accompanies these emotions during the day. In this way, dreaming may act as a kind of rehearsal space, a place to encounter threats, navigate social challenges, and work through unresolved feelings in relative safety. This also explains why dreams can feel so emotionally intense. Deep within the brain, limbic regions like the amygdala become highly active during REM sleep. The amygdala is central to processing emotion, particularly fear and arousal. Its heightened activity during dreaming floods the experience with feeling, even when the narrative itself is fragmented or illogical. The emotions are real, even if the events are not. So dreams have meaning, not symbolic meaning, but functional meaning. They serve the living organism. They help it learn, adapt, regulate, and prepare. And yet, while dreaming, none of this feels like a process. It feels like reality. The question then becomes, why do dreams feel so real? The answer lies in the unique neurochemical and neural state of the dreaming brain. During REM sleep, levels of a neurotransmitter called acetylcholine rise sharply. Acetylcholine is involved in attention, perception, and the construction of vivid sensory imagery. Its abundance during dreaming is part of what makes dream visuals so rich, so detailed, so immersive. The mind paints with a full palette. At the same time, levels of serotonin drop. Serotonin plays a role in memory consolidation and the transfer of information from short-term to long-term storage. Its absence during REM sleep may be one reason why dreams are so easily forgotten. The brain is not prioritizing the retention of these experiences. They are allowed to fade. But perhaps the most striking change occurs in the prefrontal cortex, the region responsible for logic, planning, self-reflection, and critical thinking. During REM sleep, activity in the prefrontal cortex diminishes significantly. The part of the brain that would normally question inconsistencies, notice impossibilities, or recognize that something does not make sense is largely offline. This is why, in a dream, a person can fly and feel no surprise. Why a stranger's face can shift into a friend's and provoke no confusion. Why time can loop, or a room can be two places at once, and the dreamer simply accepts it. The prefrontal cortex is the editor, the critic, the skeptic. And in dreams, it is silent. There is also the matter of movement. During REM sleep, motor neurons are inhibited. The body lies still, paralyzed, even as the brain generates commands for action. But those commands do not disappear. They are redirected inward, translated into imagined movement. The dreamer runs, but does not move. The dreamer speaks, but makes no sound. This motor inhibition is why flying feels effortless, why impossible physical feats seem natural. The intention to move is there. The sensation of movement is there. But the body remains at rest. And so, in dreams, lies go unquestioned. Impossibilities feel ordinary. The mind accepts its own creations without resistance. But not always. There are moments, rare but undeniable, when something shifts. When the dreamer becomes aware, mid-dream, that they are dreaming. This is lucidity. Some people experience lucid dreams regularly. Others encounter them only once or twice in a lifetime. But when lucidity occurs, the nature of the dream changes. The dreamer gains a measure of control. They can choose where to go, what to do, how the narrative unfolds. The passive experience becomes active. The observer becomes a participant with agency. Lucid dreaming has drawn interest not only from researchers, but from clinicians. It is being explored as a potential treatment for recurring nightmares, particularly in people who experience trauma-related sleep disturbances. The idea is simple. If a person can become aware within the nightmare, they may be able to alter it, confront it, reduce its emotional grip. The dream becomes a space for healing rather than a space of helplessness. This introduces a new dimension to the experience of dreaming. It is not always something that happens to a person. Sometimes, it can be something a person does. And yet, even as the study of dreaming reveals these mechanisms and possibilities, it also reveals how varied the experience can be. Not everyone dreams in the same way. Blind people, for instance, dream, but those who have been blind from birth experience dreams that rely more heavily on sound, touch, and spatial awareness than on visual imagery. Their dreams are no less vivid, no less immersive. They simply draw from a different palette of sensation. Some people dream almost exclusively in rich, cinematic images. A small percentage of people report dreaming mostly in black and white, though this appears to be more common among older generations who grew up before color television became widespread. The medium through which a person encounters the world may subtly shape the medium of their dreams. Children, too, dream differently. Their dreams tend to be shorter, less narrative, more fragmented. And nightmares peak in frequency during early childhood, particularly between the ages of 3 and 6. This is a time when the imagination is expanding rapidly, when fears are being named and processed for the first time. The dreaming mind of a child is still learning how to organize experience, how to regulate emotion, how to construct coherent stories from the raw materials of thought and feeling. Dreaming, it seems, is not a single phenomenon. It is a spectrum of experiences, shaped by biology, development, sensory history, and individual variation. And it may not be unique to humans. Rats, when placed in mazes during the day, show specific patterns of neural activity in the hippocampus, a region involved in spatial memory and navigation. During sleep, those same patterns replay. The neurons fire in sequences that mirror the rat's movements through the maze. The rat, in a sense, is dreaming of the path it traveled. It is replaying the route, consolidating the memory, preparing for future navigation. Even more striking are observations of octopuses during sleep. These creatures, so distant from mammals on the evolutionary tree, show periods of rest that resemble REM sleep. Their skin changes color in waves. Their eyes move beneath closed lids. Their bodies twitch, as though responding to some internal experience. Whether this constitutes dreaming in the way humans understand it remains uncertain. But it suggests that something like dreaming, some form of active neural processing during rest, may have emerged more than once in the history of life. And yet, not all animals dream. Some lack the neural complexity required. Their sleep is deep, restorative, but without the elaborate mental theater that characterizes REM dreaming. Dreaming, it appears, requires a certain threshold of brain activity, a certain richness of neural architecture. This leaves the viewer with a sense of awe. Dreaming is not a quirk of human psychology. It is a phenomenon woven into the biology of complex nervous systems. It appears in mammals, in birds, in cephalopods. It serves functions that transcend culture and language. It connects the sleeping mind to something older, deeper, more fundamental than any individual experience. And so, each night, the mind enters this ancient space. It processes, it regulates, it rehearses. It constructs worlds from memory and emotion. It accepts impossibilities. And sometimes, just sometimes, it becomes aware of itself. What unfolds in that awareness is still being explored. But one thing is clear: Dreaming is not a byproduct of sleep. It is one of sleep's purposes, and it reaches far beyond the human. The night continues. The dreams continue. And somewhere, in the quiet, the mind is at work. And so we return to where we began, to that world that opens every night. That world of vivid intensity and gentle forgetting. Tonight, as sleep arrives, the process will begin again. The body will grow still. The mind will drift into its cycles. And somewhere in the depths of REM sleep, dreams will unfold. Narratives woven from memory, emotion, and something older than language itself. Most of it will fade by morning, but that does not make it meaningless. The dreaming mind is learning, processing, regulating, preparing. It is doing the quiet work that makes waking life possible. So let the dreams come. Let them be strange. Let them be forgotten. They have already served their purpose. Rest well.